Okay, excellent. All right, well, hello everyone, and welcome to today's live session from Autocomplete to Architecture, Scaling Cursor for the Enterprise with Tabnine Context. We're thrilled to have you join us. As we give everyone a few moments to settle in, I want to quickly go over a few housekeeping items here. Today's session is recorded, and we'll share that recording with all registrants after the event. As our speakers present, you'll likely have questions about how these concepts apply to your own engineering environments. Please submit your questions at any time using the chat, and we'll answer them in our Q&A towards the end, so don't worry. All right, let's get started. First off, Cursor is undeniably powerful, and it can generate strong code and predict your next action with striking speed. But as many enterprise engineering teams are discovering, without organizational context, it is still operating like a brilliant outsider. Fast, capable, but occasionally blind to how your systems actually work. Enterprise engineering is not isolated. Without a persistent understanding of architecture, cross-file dependencies, and implicit business logic, AI suggestions can introduce hidden risk, break downstream systems, and require constant supervision. Instead of true engineering acceleration, developers end up acting like context managers. So today, we are going to show you how the Tabnine Context Engine turns Cursor into organizational aware engineering partner by grounding Cursor's tab autocomplete and compressor agents in your repositories, services, architectures, and standards. Teams dramatically reduce rework, prevent architectural drift, and accelerate delivery with confidence. We'll look at real workflows where context-powered Cursor delivers up to 2 times higher first pass accuracy in multi-file refactors, up to an 80% reduction in LLM token usage by eliminating context window thrashing, and reduces senior engineer review time from over 11 hours a week to under 3. Geez. So to guide us through this demo-driven discussion, I'm joined by 2 leaders driving the vision here at Tabnine. Please welcome John Feeney, Principal Architect in the CTO Office of Tabnine, who brings extensive expertise in designing robust systems and architectures that enable AI to thrive in complex enterprise settings. And joining him is Ori Yasser, Chief Product Officer at Tabnine, who is instrumental in shaping the product vision and ensuring our solutions meet real-world needs of developers and organizations. John, Ori, thank you both for being here. Ori, I'll hand it over to you to kick things off.
Great. So hi, everyone. Like Lee said before, the main course where John will present how this really looks in action, I would like to take a few minutes and give you the background on all the underlying assumptions of why we came with this product, what is the need, what is the main pain that we believe and we see it helps our customers solve. We all work with agents, we all hear about agents, and we all know that there's an amazing trend, no one could have seen it before, a few years ago, of unprecedented autonomy that we give agents in our workflows. Agents are writing code, agents are reviewing the code, agents are writing tests to check the code that was reviewed. You don't need us to know that. Your entire LinkedIn feed is full with stories about that. But is it really the current reality in large enterprise organizations? Well, large enterprise organizations require trust in order to implement new processes, let alone autonomous processes. And from what we see now, the answer for that is no, or if I'll be more accurate, not yet. The reality is that agents are not being fully exploited in the enterprise environment, and are not living up to the promise yet. And this is for a few reasons. First, enterprise organizations have complex architectures. There are multiple services in CI/CD pipelines. You have to interact with many interdependencies that took years to build. Some of them are based on legacy code. This is not necessarily an environment that agent will thrive in out of the box. You have a lot of business logic, critical rules that have been built throughout the years of your organizations for good reasons. You can find them in different documentations, different tickets, different Slack messages. There's nothing which is fully documented and clear end to end. And so basically, you're introducing the agent into the organization. You're using Cursor and you're using the new Opus model or GPT 5.5. It's a brilliant engineer. It's a brilliant artificial engineer, knows everything about the world, but doesn't know a lot about your organization. And without that, this engineer, this artificial engineer, can work great in isolated scenarios, can work great on doing mock-ups and greenfield projects, standalone tasks, but cannot really perform well, or you wouldn't trust it to perform well within your environment. And what is missing, or the missing layer in order for this to happen, is providing this agent, providing this genius with your organizational knowledge. And this is basically the solution that we have built here in Tabnine. Agents need a map of your organization. They need to know how the organization code base is built, what is the relationship between different components, was the underlying architecture, why we have built all those features and capabilities, what are the rules that we operate by, and what are the constraints that were given. Agents has to have the big picture in order to perform well within your organization, find the right answers, find the right solutions that are relevant for every specific enterprise. So this is basically the layer that we're introducing to the market. You already have the best LLMs out there that you can use, again, being the Claude family of models, or being the GPT family of models, or whatever you're using. And you already have great agents. You're working with Claude Code, or you're working with Cursor, like the demo that John will soon show. In order for them to operate the best possible way for your organization, you need to have the third layer, which is the context engine. What is the Tabnine Context Engine? Basically a system that takes all your organizational knowledge, code, docs, tickets, support issues, what have you, and create an intelligence layer based on that, finding the solutions, finding the connections between the different components, building the graph, if you may, that creates or illustrates the relationship between them, and exposing them to the agent. So for any task that the agent was given by a human or by another agent, they'll be able to retrieve the right context, the relevant context, and to make sure that this task is not only being executed well, but in the way that adheres to your organization's rules and standards. So summarizing this all up, what is Tabnine Context Engine? A continuously evolving knowledge layer that is specified and personalized for your organization. You can ingest multiple sources. It's always up to date. Obviously, enterprise grade security and customizable, which means that the platform is agnostic to the different types of data, the different types of knowledge that you provide to it, and that you can create different relationships that you want or that you need between them. Once you have that, agents can operate with shared memory, consistent understanding, and deep system awareness, regardless of the agent that you're working with, and regardless of the LLM that you are working with. So at that note, I would be happy to ask John if you can please demo that and show everyone how exactly this looks and the value that it provides.
Sure thing, Ori. And hopefully I am sharing my screen right now. I'm just trying to organize things here. Hopefully you can see my screen. So thanks for that, Ori. Yeah, my job here, hi everybody. My job here is to provide you with a live demo of the context engine. And so with this live demo that I've prepared, I'm going to tackle a scenario or a problem that is quite commonly faced by developers and by teams that are working with agentic AI. And that problem is that agents, they work very often in isolated sessions, and so they don't have access to all of those past decisions that we've made, or they're not aware of the architectural intent behind some of the work that we're doing. And so what that means is that developers then have to build that context, and it can be quite time consuming, and it really undermines the speed that agents were meant to deliver. And if developers don't go to that trouble and that time to build that context, and they push their code, while it's syntactically correct, very often it's just not acceptable to the business in some way. Maybe we're using the wrong library, or we're not following best practices or tried and tested patterns. And so the code change gets rejected at code review time, goes back to the developer. The developer has to reprompt, correct the code. And it's those correction cycles then that become the big killer of velocity. So that's the scenario that I'm kind of going to cover as part of this live demo. And what I'm going to do in the demo is I'm going to have two separate cursor IDE instances, and one of them will have access to the Tabnine Context Engine and the other one will not. And throughout the demo, you will see that on the left-hand side of my screen will be the cursor instance without the Tabnine Context Engine, and always on the right-hand side of my screen will be cursor benefiting from the information that it gets from the context engine. So both of them will be given the same work, the same spec, and let's have a look at that right now. So it's a Jira ticket, and if we have a quick look at the Jira ticket here, and a quick look at what's being asked of each of these agents. So we had a situation in the past where customers were charged more than once. And so what we want to do here is we want to make a change to the order submission service, and we want to prevent that from happening in the future. And as part of that, we want to introduce an idempotency key header. We want to make sure we reject duplicate submissions and that we validate the keys on the server side. And there was a past instance that is the driver behind this change. So we're going to give this to both cursor instances and see how they do. And we'll do a compare and contrast between the two, so you can kind of see clearly the importance of context and the context engine. So let's have a look then at the code base against which this change will be implemented, or where the changes will take place. So it's a Java-based monorepo, and each folder in this monorepo is a Maven submodule and a service in its own right. And so the service that's going to be affected as part of this work is will reside within the order submission service directory or folder here. So both cursor instances will be given an exact replica of this monorepo. The only difference between these two mirrors here is just in the cursor config, where on the right hand side here we're providing in the MCP config there will be a configuration for the context engine. So that cursor instance will be able to talk to the context engine, and other than that there are some additional instructions in here for the instance that will be talking to the context engine. And these instructions pertain mainly to the context engine. So we're saying things like, you've got access to the context engine. When you get information or context from the context engine, obey that context. For demo purposes, I've also put in some instruction here around narration or citations. So if the agent finds inspiration from the context engine with which it will generate code, it should provide citations for that inspiration. So it's just really good for demo purposes. And then beyond that, both agents will have access to a GitLab MCP tool as well, so they can create a merge request once they've completed their work. So really the two agents or cursor instances will have an exact replica of the code each, right? No differences whatsoever. Okay, so let's have a look then at cursor. So again, left and right. On the left, where we have cursor without context engine. On the right, we have cursor with the context engine. And so we're going to provide the same prompt to both of these agents. So I'm going to kick off both of them here at the same time. And we're going to see both of them begin their work. And the first thing they're going to do, obviously, is they're going to retrieve that Jira ticket using an MCP server that we've provided, an Atlassian MCP server. So you can see on the right-hand side here, that's already started. So they're beginning to kind of run through all of the steps. And to make things a little bit clearer, it's not going to be very, very clear here watching these two cursor instances side by side. So to kind of maybe follow things a little bit more clearly and to see things at a more high level, I've created a hook in both of those repos so that both of these cursor instances will relay information to a web app that I've created about what tools they're using. And so I'm going to switch over to that web app right now, and it's over here. And you can see we're capturing all of the tool calls from both cursor instances here. So you can see on the left that, and on the right, that they have both used that MCP server to get the Jira ticket. And you can see on the left that the cursor instance here on the left is off to the races. It's exploring the code base and determining what's in the local code base and what it needs to do to be able to satisfy the requirements in that Jira ticket. And then there's a big contrast to the right-hand side where you can see we've already had two calls already out to the context engine, the Tabnine Context Engine. And one of them is the cursor basically asking for more information about this order submission controller class that it knows it needs to make a change to. So what I'm going to do now is I'm going to switch over to the Tabnine Context Engine and show you some of the information that's in there that's going to be returned to cursor. So let's switch over to the Tabnine Context Engine then, and we'll come back to that. We'll come back to those cursor agents and that web application in a few moments. You know, it'll take some time for them to complete their work. So in the meantime, we're looking here at the Tabnine Context Engine, and specifically within the Context Engine, we're looking at the Context Explorer. And so if I zoom in here, you can see the world view that we have for this particular project. So we can see within that repository all of the various services that make up that code base. We can see as well all of the various incidents that occurred in the past that are related to these services. We can see as well some architectural decision records that have been captured in here in the knowledge graph related to those services and those incidents. And we can even see as well the team that belongs to each service. We can see the Git, the Jira tickets. So everything is in here. The thing that we're most interested in for this demo is the order submission service. So let's zoom in on that. So again, going in there, there's the order submission service that we're working against right now. And here it is. So we want to focus on this and all of the entities that are related to this. So I'm going to just isolate this so we can kind of take away a lot of that noise. And what you can see here is, first of all, when cursor talks to the context engine through an MCP server, it's going to inquire about the file that it needs to make a change to, and it will see that that file is associated with this order submission service. What it will also then see by walking this graph is it will see that incident that we saw referenced in the Jira ticket, and it'll see the details associated with that incident. As well as that, we'll see over here an ADR that was born out of that incident, and we can see the details of that decision record in a moment. And you can see there are 2 other ADRs related to this service and to that past incident. So this is very, very important context. And when, as I say, this is all exposed to external clients through an MCP server, right? So there are tools exposed, and we saw a couple of those tool calls already. So the agent will be able to inquire about the service and the files that it needs to change, and then it'll see the entire entity chain in here and pull back all of the context that it needs, right? So this is a big time saver. It doesn't require, the developer does not need to build this context. It's already in the graph here. Now, the Tabnine Context Engine also provides a number of ingesters, and there are out-of-the-box ingesters. So you can connect your Git repo. You can, for this demo, we've also connected PagerDuty. We've connected Confluence. You can connect any data source to the Tabnine Context Engine, and there are a number of out-of-the-box ingesters that will be able to discover all of your entities and ingest and create them within the knowledge graph. So here I have services and ADRs and instance, but you can literally bring anything from across your systems landscape or your application landscape into the context engine. And I can talk about that a little bit more later on. So what we will do now is I want to show you some of the contents of these assets or entities in more detail, because this is going to inform the code that is generated by the cursor instance that has access to this context engine. So I am going to switch over here, and in here I've pulled together those various assets into one place so you can see them. So we saw in the knowledge graph this incident in the past. So if we open this up, we can see that in this past instance we have it's a full post-mortem here. So we can see the root cause of the incident, how it affected users. As I mentioned before, customers were charged more than once. And so the lessons learned here ultimately were that we should not use the Spring retry library in our applications, but instead we should use this CTX retry internal library instead. And this is captured and articulated more fully in this ADR here, which I'm going to now look at as well. So if we go back, we can see we've got 3 ADRs that we saw in the knowledge graph. This one that was referenced by that instant directly has details about how to include that retry library in your application. The package resides at this package registry location, and all the details that you would require, right? So this is very important institutional knowledge that we want to make sure our agents have access to. We have another ADR here that again does reference that library that we just talked about, but also it mentions other things such as the idempotency keys must be in UUID v4 format. So that's really important to know as well. And also when we're introducing idempotency keys, we should create a unique constraint on them in the database. So again, this is very, very important context. And then finally, I just want to show you this last one as well. This one mandates that we use a specific key value for our HTTP headers for the idempotency key. So I'm showing you all this because all of this is going to surface in the generated code, or at least we hope so, once the cursor instance that has access to the context engine has completed its work. All right, so let's switch back then to our HUD or our web application where we're capturing all of that. Sorry, it's in here. Okay, so I can see that on the left-hand side, the the cursor instance without access to the context engine has already completed its work and it's created a merge request. So we'll have a look at that now in a moment. And we can see on the right-hand side here, again, this cursor instance is still working away. But what we can do is go back into cursor. We'll have a look. I think, okay, sorry, I'll switch back here because I just saw a call going out now to the context engine to get the code reviewers from the context engine. So we're at the point here where this one is almost finished as well. It's about to create the merge request, and it's getting, it wants to get information about the team that the service belongs to and who the code reviewer should be. So we'll have a look at that in a moment as well. Just want to go back to cursor itself. And on the right-hand side, again, where we have access to the context engine, I just want to scroll back up through the conversation here. You can, I think it's worthwhile showing you here the to-do list that cursor has created for itself. And it's a very specific to-do list, and it's shaped very much by the information that it received from the context engine. So you can see a mention of that retry library, internal library that we need to use. It's using the UUID v4 format as we saw in those artifacts. So you can see this is a very much shaped. Here's that X idempotency key header value. So this is very much shaped by what it saw in the Tabnine Context Engine. And so, we do expect to see very different code on the right-hand side here to what we will see on the left-hand side. So let me have a look and see. It's still creating that merge request in GitLab, and actually it's just completed that now, and it's actually completed all of its work. So I think we're ready now to do a quick comparison of the code on both sides and see what the result of this is. So, and a quick look at the HUD again. So yeah, we're completely finished. So we've had 3 different calls out to the context engine on the right-hand side here. Okay, so let's go back to the code base. And this is going to be a very worthwhile comparison to really kind of drive home really the importance of context and how the context engine, the Tabnine Context Engine, can really deliver, create a really low barrier to building context as you're doing your work. So this is the service that was affected. So we're seeing some changes in here on both sides. Straight away, I can see in the POM XML, there's a change. So let's look at that. And so on the right-hand side, we can see that this cursor instance has understood that we need to use this internal library, and it has created the necessary change in the POM XML for the service. And you can see as well, in our instruction, we said, do narrate all of the work that you do where you found relevant context from the context engine. And so we have a couple of citations here that really explain why this change is in here. So that's nice to see. So we can see straight away some substantial differences in the changes on both sides. So going in here again, let's have a look. So we have the same file has been modified on both sides here. So there's a database migration script. And what you can see here, again, we have these citations on the right-hand side. And what's really important is we have, for this new idempotency key column that we've created for the orders table, as we saw in one of the ADRs, we have this unique constraint that's created for that new column. And we can see that that's completely missing on the left-hand side. So straight away, this is not going to work in production on the left-hand side. And this is something that's going to get rejected at code review time. So that's the database script. Let's go into the actual code and see what we see in here. So again, substantial changes. So if we open up this and make this a little bit bigger so you can all see, Again, citations, as we would expect. And you can see this is the HTTP header value that was called out in one of the ADRs, and that's missing. In fact, it's not missing, but it's completely, Cursor here has provided a best guess or a best estimate as to what that key should be, and that's obviously not going to work either in production. And so we can see down here substantial changes. It's really stark, the differences in the code on both sides. And we can see that there is also this UUID v4 implementation, and I think it's been done through a new class called Key Validator. So let's have a look for that. I think it's in here. So let's have a look and make this a little bit bigger. And yeah, you can see that UUID for v4 implementation is present on this side here, and it's missing from the other side. So some big changes there again. And if we have a look at this, the order class, again, the context that we received from the context engine on the right-hand side here has spawned this relevant change. And you can see again, this kind of maps to the database change that we saw with that unique constraint here. We have a unique equal to true declaration in here. So you can see, so I mean, I think, there's enough examples here for you to really kind of see, the dramatic difference in the two, in the code that's been generated by both Cursor instances. The Jira ticket itself, even though it was quite a detailed spec and you would think that would be enough, it really isn't, because as any of us who are developing for enterprise code or developing against enterprise code bases, as we know, these code bases don't live in isolation. There's a lot of institutional knowledge that surrounds that code, that lives in many different systems. And, it's really, really vital that is brought, to the table when we're asking our agents to generate code. So going back to Cursor again, one of the last things that we asked both of them to do was to create a merge request in GitLab for the work. So let's have a look at that. So I have a link here on the right-hand side, and I have a link on the left. So let's have a look at the right-hand side first. So I'm just going to open up this MR. Okay. And so, as you would expect from a agentic AI, quite a detailed description of the change. But what's nice to see in here is, thanks to the information we got from the context engine, we have, again, all of those citations in the MR. So all of those ADRs and all the directives within those ADRs are called out here, and it's pointing out to where in the code we satisfy these directives. And this is really something that's going to be quite useful for code review, and will ensure that we don't have to go back and correct this code. I mean, this should be a one-shot fix for that ticket. We can see as well on the right-hand side, thanks to that call to the context engine where we got the code reviewer, we were able to see what the team was. So we have the correct label applied to the MR. So this is the correct team that owns this work. And this is a member of that team who has been automatically assigned a reviewer for this MR. Now, if we go back to the other Cursor instance and we have a look at the MR that it created, let's see if I can click on this and open this up. So this is really very different. The first thing you'll notice, we have no reviewers assigned on this side, because obviously that Cursor instance didn't have access to that information. And you can see it's made a best guess attempt at what the label should be. And also in the description, we're missing all of those references to that institutional knowledge and all those directives that we saw in those ADRs and those incidents. So a big difference between the two instances. So, just to kind of recap on what you've just seen, really, when you've seen that context is really all important. You've seen as well how the context engine can expose all of the artifacts from across your entire application landscape very conveniently through an MCP server. So when you're evaluating your current AI vendor, or if you're looking at a new one, the question is not, can it code? Because of course they all can code. I mean, the frontier models that we have today are really quite accomplished. So that's not a question anymore. The question really is, can it generate code that's in accordance with our best practices, with all of the past decisions that we've made, with all of the institutional knowledge that exists across our organization? So that really is the question. And I would encourage you all, to think about that with your AI vendor. And, based on what you've seen here, if you think that Tabnine's context engine can help you in terms of, increasing the quality of your code or accelerating your software delivery efforts, please do give us a shout. We'd love to hear from you, and we'd love to explore that with you. So, Lee, with that, I think we might move on to Q&A if there are any questions.
Yeah, absolutely. Great session, John. Really insightful. A couple questions here I wanted to bring up. First, do I need to structure my code or my Jira tickets in any particular way in order for them to appear in the knowledge graph?
No, you don't. You don't need to jerry-rig your code base or any of the data in any of your systems in order for it to appear in the knowledge graph here. So we have a number of ingesters that are available out of the box, and I can show you some of those. If I go into data sources here, you can see the data sources that I've created for this project and for this demo. And you can see, if I go to add data source, you can see that there are a number of ingesters or connectors. Sorry, these are data sources that you can connect to the context engine. So you've got all the various source control systems, version control systems, you've got the issue tracking systems, all of those popular locations for documentation, CI/CD, and so on. Now, we have a number of out-of-the-box ingesters as well that will traverse those data sources. And, the one that I used a few of them for this demo. So one that I used, so you'll notice that there's a whole bunch of services appearing in the graph here. So one that I used was something called Find Services. And what it does is, out of the box, it understands what services look like for across many different languages. So I was using a Java-based and a Maven-based project today. So it was able to see that there was a POM XML in the root of all of these Maven submodules. And so it identifies those as services. But it's also able to look at the source code within your repo as well. And so for Spring Boot based source files, if it sees like a REST controller annotation, it knows that is a service. It can also look at if you've got an open API spec in the repo, it can look at that to see what the endpoints are. It can see all of the references to databases. And as I said, it supports all the various different languages. So today I was using Java, but for JavaScript, Node.js, it might look for package.json files in the root of the repo, go.mock files for Go projects. So this is something that it does out of the box, and that might work for you, or it might not. And if it doesn't, it's very easy to create your own ingester. And in their very simplest form, these ingesters are prompts to an LLM to say, this is how you find the entities in my data source, and this is what they look like. And it can use that information then to pull those out and then create those entities in the knowledge graph. So you've got out of the box ingesters that hopefully will work for you without any modification. And if they don't, you can create your own very simply and very readily.
Great question. Great answer. We have one more here. It's on top of the mind of many of our customers and prospects. Can we use the context engine outside of the Cursor IDE?
Absolutely. So as I mentioned, all of the information that we looked at today, that is exposed through an MCP server. There's a whole bunch of different tools that your external agent can leverage and use. So today we used Cursor in the IDE to make those MCP tool calls, but you could do that equally through Cursor CLI, or indeed any other coding assistant. Claude Code, we did a demo of that a couple of weeks ago. Or alternatively, you could make these calls from within your CI/CD pipelines, right? So you can either make those calls through the MCP layer, or we also provide APIs, direct API endpoints as well. So you could call those directly to get information from the context engine. And then just, I guess, maybe one additional note to make you all aware of is that Tabnine also provides its own CLI coding assistant. So you could run that in your CI/CD pipeline, and that will be able to natively talk to the context engine as well. So you've got a few different avenues that you can pursue there. But absolutely, it's not limited to IDE-based agents. You can use it pretty much anywhere where you can run an agent.
Amazing. Well, let's see. It looks like that's the extent of our questions. Unless anybody has any other questions, let's look at the time. Yeah. Seems like we're just about out of time here, but
well, what I would say, Lee, just to expand on those two questions that we just received, what you're looking at here, it's important to kind of know that what you're looking at here is not a one-shot snapshot or a stale representation of what exists across your application ecosystem. Really, this is a living graph. So these ingesters that I was talking about just a few moments ago, they can run in a variety of different ways. They can run on a cron schedule, right? Or they can be triggered asynchronously from some external event, like through an incoming webhook. So say, for example, you've pushed code into a repo, that could be the trigger to call one of these ingesters to run again. And then, of course, you can run these ingesters and these agents manually as well, of course. But what this all means is that you're looking at a living representation of all of the artifacts across your heterogeneous systems, and that's really important to know. And I guess another kind of common question that I get on that is like, well, if we're concerned about token consumption, what can we do in that regard? And so these agents, they are powered by LLMs, but you can also create more deterministic versions of those agents. So, you can drop in a script that, is designed to pull out entities from your various systems. And so you can do that as well. But I guess the important thing to point out is that, this is a live, living and breathing representation of what's going on in your organization.
Excellent. Great clarity there. Or any final thoughts from you?
Yes, maybe to extend an invitation for everyone here. If you want to share with us your challenges in implementing the agentic workflows in your organization, whether it's directly connected to the context or other issues, we have a significant expertise in helping customers doing that. So we'll be happy to take a call and to help out in doing that and showing the amazing value that agents can bring to your organization as well.
Excellent. And I know Context provides an incredible amount of value across LLM token savings, reviewer time value, even down to senior AI rework value. So we invite you all to engage with us to have a custom demo so that we can really evaluate the context engine in your real world environment. So With no further questions, I want to give a huge thank you to everyone who joined us today. The engagement and the quality of questions were really great. If we did not get to your specific questions or you're watching this after the live event, we'd love to have our team follow up with you directly via email or face-to-face. And you can do that in the book a demo meeting link at the bottom. So John, Ori, thank you both for sharing your invaluable insights. It's clear that if you're using Cursor today and want enterprise-grade outcomes tomorrow, structured context is the key to transforming raw AI capability into dependable engineering performance. Having that deep, persistent understanding of an organization's systems and constraints is really critical foundation for operational safety at scale. And those of you who are listening, who are dealing with these exact challenges, navigating complex architectures, managing dependencies, and trying to make AI work reliably within your specific organizational constraints, we'd love to show you how this works in practice. Again, we invite you to connect with our team for a personalized one-to-one demo. We can walk you through your specific environment and show you exactly how the context engine can map to your systems and empower your AI agents to reason and operate safely. You'll see the link at the bottom to schedule your session, or you can always reach out directly at context.tabnine.com. But again, thank you for your time, your questions, and your participation today. Have a great rest of your day, and we look forward to speaking with you soon. Cheers.
Bye, everybody.